everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about analysis of coal, ultimate analysis. What is the significance of ultimate analysis? So these are topics today we are going to discuss in this session. So first, what is fuel? So already we know that fuel is a combustible substance. It containing main constituent is carbon. So during burning process in the presence of oxygen, it produces heat energy, is known as fuel. So see here, fuel is a combustible substance. It containing main constituent, main element is carbon because it increases the calorific value. So what is the meaning of calorific value? During how much amount of heat liberated when a unit mass of fuel is burning. That is called calorific value. So fuel efficiency is decided by this calorific value. So carbon is the main constituent of fuel. So it increases the calorific value. So here main constituent is carbon. So which burning it gives large amount of heating. Large amount of heat during the process of combustion of a fuel. So burning process, that is called combustion. Burning of fuel in the presence of oxygen. This process is called combustion. So during heating process, what is the reaction takes place here? Fuel, when it is burning in the presence of oxygen or oxidation. So in this case, it forms combustion product plus energy. So fuel during burning process in the presence of oxygen, it produces combustion product and energy. This process is called combustion. That energy is used for domestic and industrial purpose. So fuel is a main combustion substance, combustible substance. It containing main element is carbon. Carbon increases the calorific value. So during burning process in the presence of oxygen, it produces heat energy. This process is called combustion. That heat energy is used for domestic and industrial purpose. So if in case in the fuel is present carbon, hydrogen or sulfur, any element present in this fuel. So the atoms of carbon, hydrogen, etc. combine with oxygen with simultaneous liberation of heat is known as fuel. If in case in the fuel during burning process, it containing carbon. So during burning in the presence of oxygen, so carbon reacts with oxygen, then it produces carbon dioxide and it releases energy 94 kilocalories of energy. For example, in the fuel during burning process, in this fuel containing hydrogen. So during burning in the presence of oxygen, so this fuel interacts with oxygen, then form combustion product is water and it releases 68.5 kilocalories of energy. So this energy is used for domestic and industrial purpose. So the main source of fuel is coal and crude petroleum. The main source of fuel is coal and crude petroleum. So these are stored fuels available under the earth crust. How to form these fuels? How can we obtain these fuels? Mainly the main source of fuel is coal and crude petroleum, which is obtained from under the earth crust. Under the earth crust. That means the plants and animal materials buried under the earth crust in millions of years. Partial combustion of these material plants and animal materials buried under the earth crust in a million of years then converts to fossil fuels. Then converts to fuels is named as fossil fuels. So now we'll discuss classification of fuels. So fuel means during burning process in the presence of oxygen, it produces heat energy that is used for domestic and industrial purpose. That is called fuel. The process is called combustion. So these fuels are classified into two types: primary fuels, secondary fuels. Primary fuels, secondary fuels. So primary fuels, these are obtained from nature. These are obtained from plants and animal materials or nature. These are also called as natural fuels. Secondary fuels, It is also called as artificial fuels. These are made from primary fuels. These are obtained from primary fuels. So again, this primary and secondary fuels subclassified into three types: solid, liquid, gaseous fuels. So based on physical state, this primary and secondary fuels again subclassified into three types: solid fuels, liquid fuels, and gaseous fuels. So solid fuel, best example is wood or coal. Wood or coal is the primary solid fuel. And liquid fuel is petroleum, crude petroleum. And gaseous fuel is natural gas. And again, secondary class fuels or artificial fuels also subclassified into three types: solid, liquid, gaseous fuels based on the physical state. So secondary solid fuel is charcoal. Secondary solid fuel is charcoal. And secondary liquid fuel is petrol, diesel, kerosene. These are obtained from primary fuels. And secondary gaseous fuel is coal gas, water gas, etc. So classification of fuels. Fuels are classified based on the physical state. Our first fuels are classified into two types: primary fuels, secondary fuels based on occurrence. So primary fuels, they are obtained from nature. That's why it is also called as natural fuels. Secondary fuels, it is also called as artificial fuels, which are made up from primary fuels or man-made fuels. Artificially prepared fuels are called secondary fuels. So again, these primary and secondary fuels subclassified into three types based on their physical state, which are solid fuels, liquid fuels, and gaseous fuels. Now let's discuss solid fuels. So already we know that coal is the primary solid fuel. Coal is the important primary solid fuel. So which was formed under the earth crust from the plant and animal material by partial combustion under high pressure in the absence of air through millions of years. Just simply we says plants and animal materials buried under the earth crust in millions of years under high pressure and partial combustion, then convert to fossil fuels. So best example of solid fuel is coal. Coal is the primary solid fuel and most important primary solid fuel. So how to convert this wood into coal? What are the steps involved in this? So first one is wood. It converted to next level is peat, lignite, bituminous coal, anthracite coal. So wood convert to anthracite coal. What are the steps involved in this? First, wood converted to, here see this diagram, peat, then lignite, bituminous coal, and anthracite coal. This anthracite coal is used for industrial purpose also, domestic and industrial purpose we are using this one. And here from wood to anthracite coal, here moisture content, volatile matter, and hydrogen, oxygen, nitrogen, and sulfur content decreases from wood to anthracite coal. Moisture content, volatile matter, and elements of, for example, hydrogen, oxygen, nitrogen, sulfur, etc. These percentages are decreases. And carbon content, hardness, calorific value increases. From wood to anthracite coal, this moisture content, volatile matter, ash content, and hydrogen, oxygen, nitrogen, sulfur, these elements percentage also decreases. And calorific value and carbon content, hardness, these values are increases. So now let's discuss analysis of coal. Generally, what purpose we analyze coal? So generally we are using coal is the important primary solid fuel. It is used for domestic as well as industrial purpose also. So before usage this coal, we analyze it. Analysis of coal is most important to fix the price and quality of coal. To fix the price and quality of coal. And also used for which type of coal is suitable for some special industrial applications. So that purpose we analysis of coal is most important to fix the price and quality, and which type of coal is suitable for specific industrial applications. So coal is analyzed by following these two methods, proximate analysis and ultimate analysis. So proximate analysis, already we discussed previous class. How can we analyze it? What is the use of proximate analysis, and that purpose what we analyzed in this coal. So proximate analysis mainly helpful to fix the price and quality of coal. To fix the price and quality of coal. So in this purpose we can determine its involve percentage of moisture content, volatile matter, ash content, fixed carbon. So these we have to determine for this proximate analysis. That means fix the price and quality of coal. So already we discussed previous classes how can we determine this percentage of moisture content, volatile matter and ash content and fixed carbon percentage present in coal sample by this proximate analysis. And also we discussed what are the significance of proximate analysis. So now let's discuss ultimate analysis. Ultimate analysis. So it is also called as qualitative analysis of coal. It is also called as qualitative analysis of coal. So it's important to find whether the coal is used in particular metallurgical applications or not. It is not suitable for that metallurgical applications or not. It can be determined by using this ultimate analysis. So this method is also called as qualitative analysis of coal. This method is also called as qualitative analysis of coal. So in this most important is find whether the coal is can be used for particular metallurgical applications. It is suitable or not. It can be determined by using this ultimate analysis process. Ultimate analysis. So it's involved the determination of percentage of what we can determine in this ultimate analysis for which is suitable for some special industrial application purpose. It is suitable or not. It can be decided by using this process ultimate analysis. So that purpose we have to find out the percentage of carbon and hydrogen content, the percentage of carbon and hydrogen content and nitrogen content, sulfur content, ash content and oxygen percentage. So this ultimate analysis purpose we can determine the percentage of carbon and hydrogen, nitrogen and sulfur, ash and oxygen content. How much percentage of these elements present in this coal sample. So this method is also called as elemental analysis process. Elemental analysis, how much percentage of these elements present in this coal sample and which type of coal is suitable for some special industrial application purpose, which is suitable or not. So it can be determined by using this ultimate analysis process. So now let's discuss determination of carbon and hydrogen. Carbon and hydrogen percentage present in coal sample. It can be determined by using this method, ultimate analysis. So how can you determine this carbon and hydrogen percentage present in coal sample? So here, known weight of powdered coal. Known weight of which coal sample is we tested for this purpose. So that coal sample, known weight of coal sample. Known weight of powdered coal is burned in steam of pure oxygen in a heating tube. Known weight of powdered coal sample is taken heating tube and burned in steam of pure oxygen. So they burn in heating tube. So if in case carbon and hydrogen present in this coal sample, so carbon reacts with oxygen then form carbon dioxide. If in case hydrogen present in coal sample, it converts to water respectively. So first, known weight of coal sample burned in steam of pure oxygen in a heating tube. In a heating tube. The carbon and hydrogen present in the coal sample are converted to carbon dioxide and water respectively during burning process. If in case carbon present in this coal sample, carbon reacts with oxygen then produces carbon dioxide. If in case hydrogen present in this coal sample, hydrogen reacts with oxygen then produces water respectively during burning process. So next, these gases are passed first through the pre-weighed U-shaped tube containing calcium chloride, which absorbs water, and then through glass bulb it containing or glass or another U-shaped tube. It containing KOH liquid, it absorbs carbon dioxide formed from the burnt coal. So for example, known weight of coal sample burning in the presence of oxygen in a heating tube. If in case carbon or hydrogen present in this coal sample, these are reacts with the oxygen during burning process, then converted to carbon dioxide and water. So these gases are passed through U-shaped tubes. Already in these tubes, it's containing, one tube is containing calcium chloride, another tube is containing KOH. So when we pass these gases in this U-shaped, pre-weight U-shaped tubes, so this calcium chloride containing tube is absorbs water, and KOH containing U-shaped tube, it absorbs carbon dioxide. That means the levels of calcium chloride and KOH are increased due to absorption of this carbon dioxide and water. So the increase in levels indicates that the percentage of carbon and hydrogen present in coal sample. For example, so see here, this is a heating tube, this is a combustion tube or heating tube. So known weight of coal sample, this is a coal sample. So known weight of coal sample heating in this heating tube in the presence of oxygen, stream of oxygen. So in this case, just now we discussed already, if in case carbon and hydrogen present in this coal sample, these are reacts with oxygen, then produces which gases? Carbon dioxide and water gases. Carbon dioxide and water. So these gases passed in this U-shaped tube, first and second U-shaped tube. So first tube already it's containing anhydrous calcium chloride. It's containing calcium chloride. And second tube it containing known weight of pre-weighted KOH solution. So this calcium chloride absorbs water, and this KOH solution, KOH absorbs carbon dioxide. So what is the meaning here? For example, this weight of anhydrous calcium chloride present in this tube. So when we pass these gases in this tube, this calcium chloride absorbs water, so the level is increased. So the increase in level indicates the percentage of hydrogen present in coal sample. And next, this remaining gas is passed in this another U-shaped tube. Already in this tube, it containing KOH solution. So this KOH solution absorbs carbon dioxide. This KOH solution absorbs carbon dioxide. That means KOH level is increased. That increased level indicates that the percentage of carbon present in coal sample. So now discuss what are the reactions takes place. So if in case carbon present in this coal sample, so when during heating process in the presence of oxygen, it produces carbon dioxide. If in case hydrogen present in coal sample, so during burning process in the presence of oxygen, so hydrogen reacts with oxygen, then produces water. So then this gas is passed in this pre-weight U-shaped tubes. So one tube containing KOH, another tube containing calcium chloride. So this KOH tube absorbs carbon dioxide. This KOH tube absorbs carbon dioxide. Then it forms K2CO3 and H2O. So the level of KOH is increased, that expresses that the percentage of carbon present in coal sample. And next tube is it's containing calcium chloride. When we pass this gaseous water in this calcium chloride tube, this calcium chloride absorbs water. Then level is increased. Increase the level of calcium chloride, that expresses as the percentage of hydrogen present in coal sample. Then it reacts with calcium chloride, absorbs water, then it gives calcium chloride and 7H2O. CaCl2 7H2O. Hydrated calcium chloride is formed. So the increase in level of calcium chloride and KOH bulbs, that express that the percentage of carbon and hydrogen present in coal sample. So these are the reactions takes place in this determination of carbon and hydrogen. So now let's discuss how can we calculate the carbon and hydrogen percentage present in coal sample. So first one is percentage of hydrogen present in coal sample. So it can be determined by using this formula. So here percentage of hydrogen equal increase in weight of calcium chloride bulb. Just now we discussed already, when we pass this gases H2O and carbon dioxide, calcium chloride absorbs water. So here how can we determine the percentage of hydrogen? Increase in weight of calcium chloride bulb. Because calcium chloride only absorbs water. So here we are taking increase in weight of calcium chloride bulb and into 2. Here 2 means molecular weight of hydrogen. Molecular weight of hydrogen. And by weight of coal sample taken. For example, if you are taking 1 gram, here weight of coal sample is 1 only. And 18 is the combustion product water molecule H2O. Molecular weight of H2O is the 18 into 100. So how can you determine percentage of hydrogen present in coal sample? Increase in weight of calcium chloride bulb into 2 by weight of coal sample taken into 18 and into 100. This is a formula used for determination of hydrogen present in coal sample. And next, how can you determine carbon percentage present in coal sample? So generally carbon present in coal sample during burning process, it produces carbon dioxide. So this carbon dioxide absorbed by KOH bulb or KOH tube. So that's why we consider increase in weight of KOH bulb. Increase in weight of KOH bulb into 12. Here 12 is the molecular weight of carbon. 12 is the molecular weight of carbon by weight of coal sample taken into 44. 44 is the molecular weight of carbon dioxide. Combustion product molecular weight is 44 and into 100. So this is the formula used for determination of percentage of carbon present in coal sample. So here 2 and 18 is the molecular weight of hydrogen and water. And here 12 and 44 is the molecular weight of carbon and carbon dioxide. Now let's discuss determination of nitrogen. Determination of nitrogen. So this method is also called as Geldahl's method. Geldahl's method. So this purpose we are using Geldahl's flask. So what is the meaning of Geldahl's flask? Long neck, round bottom flask. This is called Geldahl's flask. Geldahl's flask. Long neck, round bottom flask is called Geldahl's flask. This method is called Geldahl's method. This method is used for determination of nitrogen present in coal sample. So how can you determine this percentage of nitrogen present in coal sample? So here known amount of powdered coal sample. Known amount of powdered coal sample heated with concentrated of H2SO4. Concentrated of H2SO4 in the presence of K2SO4 or copper sulfate. Here this K2SO4 or copper sulfate acts as the catalyst. Acts as the catalyst. So known weight of powdered coal sample heated in this Geldahl's flask and heating with concentrated of H2SO4. Concentrated H2SO4 in the presence of potassium sulfate or a copper sulfate acts as a catalyst. So these are heating coal sample, and here see this image here. This is a long necked round bottom flask. This is called Geldahl's flask. In this we are taking organic compound, that means coal sample and plus concentrated of H2SO4 in the presence of copper sulfate or K2SO4 acts as a catalyst. So in this during heating process, if in case nitrogen present in this coal sample, so nitrogen in the coal is converted into ammonium sulfate. Nitrogen present in coal sample, it converted into ammonium sulfate and a clear solution is obtained. So here see this, this is a Geldal flask. In this flask, what we are taking, which we can find out the coal sample. The nitrogen, if it is present in this coal sample. So this determination purpose, known weight of coal sample taken in this Geldal's flask, and also we are adding concentrated heating with concentrated H2SO4. Known weight of coal sample plus H2SO4, and also we are adding in the presence of K2SO4 or copper sulfate acts as a catalyst. So during heating process, it produces clear solution, that is ammonium sulfate. If in case nitrogen present in this coal sample, it is converted into ammonium sulfate. Clear solution is formed. Here see this reaction. If in case nitrogen present in this coal sample, so during heating process with the H2SO4, concentrated H2SO4, then it produces ammonium sulfate. It produces ammonium sulfate clear solution. Ammonium sulfate clear solution is formed. Next, the clear solution is then heated with, this clear solution is heated with NaOH. This clear solution, that means ammonium sulfate, is heated with NaOH, and the liberated ammonia distilled over and is absorbed is known as volume of standard N/10 HCl. That means here in the first Geldal's flask, what we are taking, known weight of coal sample heated with concentrated of H2SO4 in the presence of copper sulfate or potassium sulfate acts as a catalyst. So during this process, it produces clear solution, that is the ammonium sulfate. Next, this ammonium sulfate, in this image, see this ammonium sulfate heating with NaOH. Heating with NaOH. In this case, it produces ammonia. See here, this is a clear solution, ammonium sulfate heated with NaOH. It produces ammonia. It liberated ammonia. So this ammonia is distilled. Here, distilled. This ammonia is distilled over and is absorbed in a volume of standard N/10 HCl. N/10 HCl. So here ammonia is distilled over and it is absorbed in a known volume of standard N/10 HCl. In this case, it produces ammonium chloride. It produces ammonium chloride. Here, the volume of unused N/10 HCl, few percent of HCl used in this distillation process. So here unused HCl, it then be determined by titrating it against standard N/10 NaOH. Standard NaOH. So the amount of acid neutralized by liberated ammonia from coal. The liberated ammonia from coal is determined. So from this, the percentage of nitrogen is calculated as follows. Here, how can you determine the percentage of nitrogen present in coal sample? So percentage of nitrogen is equal 14. Here 14 is the molecular weight of nitrogen. 14 is the molecular weight of nitrogen. And here volume of acid consumed. Volume of acid consumed by titrating against NaOH. That value considered here, volume of acid consumed. And next, normality of acid, N/10 HCl. That normality is taken here and by 1000 into total 1 liters and by into weight of coal sample taken. In total, it's into 100. This is a formula used for determination of nitrogen present in coal sample. So just now discussed already. Starting, this is a Geldal's flask. This is a Geldal's flask. Long neck, round bottom flask is called Geldal's flask. In this flask, what we are taking? Coal sample, known weight of powder coal sample and concentrated of H2SO4 and copper sulfate. Here copper sulfate acts as a catalyst. Here copper sulfate or potassium sulfate, anyone we are taking for this purpose. These two are used as a catalyst. So during heating process, if in case nitrogen present in this coal sample, nitrogen reacts with H2SO4, concentrated H2SO4, then in this case it produces ammonium sulfate clear solution. It produces ammonium sulfate clear solution. So that clear solution is heated with NaOH. Ammonium sulfate clear solution is heated with NaOH. So in this case it liberates ammonia gas. So this ammonia is distilled over this N by 10 HCl. Distilled over and N by 10 HCl. Consumed N by 10 HCl. So unused HCl is titrating against N by 10 NaOH. That is clearly tells that the percentage of nitrogen present in coal sample by using this Geldas method. It is also called as Geldas method by ultimate analysis process. So now let's discuss determination of sulfur. So known weight of coal sample. How can you determine sulfur present in coal sample by ultimate analysis process? So known weight of coal sample burned in a stream of oxygen. Burned in a stream of oxygen in a bomb calorimeter. In a bomb calorimeter. So the sulfur released from coal is oxidized to sulfates. Sulfur during burning process in the presence of oxygen, if in case sulfur present in coal sample, sulfur reacts with oxygen then produces sulfates. Sulfur reacts with oxygen then produces sulfates. Then it is made to react with barium chloride. It is reacts with barium chloride solution to form barium sulfate precipitate. First known weight of coal sample taken in this heating tube and burned in bomb calorimeter in the presence of oxygen. If in case sulfur present in this coal sample, it is reacts with oxygen then form sulfates. Next it is reacts with barium chloride, then it forms barium sulfate precipitate. So this precipitate is filtered, dried and weighed to calculate the percentage of sulfur present in coal sample. First one, known weight of coal sample taken in this heating tube, burned in bomb calorimeter in the presence of oxygen. If in case sulfur present in this coal sample, sulfur reacts with oxygen, then produce sulfates, immediately it reacts with barium chloride, then form barium sulfate precipitate. So this precipitate is filtered, dried and weigh out that barium sulfate weight. So that is expressed as the percentage of sulfur present in coal sample. So how can we determine the percentage of sulfur present in coal sample? So it's equal weight of barium sulfate into 32. 32 is the molecular weight of sulfur by weight of coal sample taken into 233. It is a molecular weight of barium sulfate. Molecular weight of barium sulfate is 233 into 100. So this is a formula used for determination of sulfur present in coal sample. Now let's discuss ash content. So already we discussed previously in this proximate analysis. Same way here we are using this. How can you determine this ash content? It is similar to proximate analysis. So after the analysis of in the proximate analysis, what we can find out moisture content, volatile matter, ash content. So after completing moisture content and volatile matter, the residual coal sample is taken in crucible without lid, heating without lid. So here the crucible with residual coal sample is heated without lid at maintaining temperature ranges 700 to 750 degrees centigrade for half an hour in a muffle furnace after completing moisture content and volatile matter. So the residual coal sample taken in crucible, heating in muffle furnace. Here maintaining temperature range is 700 to 750 degrees centigrade and time duration is half an hour. So in this case, what we observe? Weight loss of coal sample. So the loss in weight expressed as the percentage of ash content present in coal sample. So the loss in weight of coal sample is expressed as the percentage of ash present in coal sample. So what is the formula we are using for determination of ash? So here percentage of ash present in coal is equal weight of crucible after heating till loss in weight of coal sample. That weight we consider here. Weight of crucible after heating by weight of crucible before heating into 100. And next one is oxygen content. So the percentage of oxygen is calculated as the percentage of oxygen in coal is equal 100 minus percentage of carbon, hydrogen, nitrogen, sulfur, ash. It is subtracting the percentage of carbon, hydrogen, nitrogen, sulfur, ash from 100. In this way, we have to calculate the oxygen percentage present in coal sample. So in this ultimate analysis mainly used for which type of coal is suitable for industrial application purpose, that is suitable or not, it can be decided by this ultimate analysis. That purpose what we can determine in this carbon, hydrogen content, sulfur, nitrogen, ash and oxygen content also. Now let's discuss significance of ultimate analysis. Significance of ultimate analysis. What is the importance of this ultimate analysis? So first one is carbon and hydrogen content. Carbon and hydrogen content. So higher the percentage of carbon and hydrogen, present in coal, so better is the quality of coal. That means it increases the calorific value. So higher the percentage of carbon and hydrogen, better is the quality of the coal. It increases the quality of coal. That means it is having high calorific value. Carbon and hydrogen percentage increases means calorific value percentage also increases. And second point is the percentage of carbon. It is helpful in the classification of coal. This percentage increases means it acts as a good coal. Always good coal contains high percentage of carbon because it increases the efficiency of coal. That means increases the calorific value. And second one is nitrogen content. So nitrogen does not have any calorific value. Nitrogen does not have any calorific value. So if in case is present in coal it is undesirable. We cannot consider because it doesn't have any calorific value. If in case nitrogen present in coal sample, that coal is we cannot consider. That means it is undesirable. It is undesirable. And next, good quality of coal should have very little nitrogen content. Good coal always containing very less percentage of nitrogen because nitrogen doesn't have any calorific value. That means it reduces the calorific value. So that's why it is undesirable. We cannot consider. If in case it containing present in coal sample, it decreases the calorific value. So always good coal contains less percentage of nitrogen and high percentage of carbon and hydrogen. And next one is sulfur content. So sulfur present in coal, it is undesirable. Sulfur present in coal, it is undesirable because sulfur, if in case present in coal sample, it is having calorific value, but it is undesirable because it corrodes the equipment where it is interacts with the oxygen during burning process. It produces sulfates. It corrodes the machine parts. That is the main drawback. So that's why if in sulfur present in coal sample, it is having some calorific value, it is okay. But during burning process, it corrodes the machine equipment due to sulfates formation. So that's why it is, if in case present in coal sample, it is also undesirable. So see here, sulfur presence in coal, it is undesirable because the combustion product of sulfur, that means sulfates are harmful and have corrosion effect on equipment. Just now we discussed already. If in case sulfur present in coal sample, in the during heating process, in the presence of oxygen, it produces sulfates. So that means it corrodes with the machine equipment. That is the main drawback. That's why it is undesirable. If in case it is present in coal sample, it is undesirable. And second one is the coal containing sulfur is not suitable for the preparation of metallurgical sulfur. It is not suitable for the preparation of metallurgical sulfur, and it is not suitable for the preparation of metallurgical coke. So it affects for the properties of metal. So always good coal contains less percentage of sulfur. And last one is oxygen content. Lower the percentage of oxygen, higher is calorific value. Lower percentage of oxygen, so here higher is its calorific value. So as the oxygen content increases, its moisture holding capacity also increases. If this oxygen percentage increases means its moisture holding capacity also increases. So in this case, and calorific value of the fuel is reduced. So always good coal containing high percentage of carbon, hydrogen and less percentage of nitrogen, ash, sulfur and oxygen. If in case ash also present in coal, it is also reduces the calorific value. That means it produces more smoke. It requires more heat energy and do not support the burning. So that's why if in case ash present in this coal sample, it is also undesirable. That means always good coal containing high percentage of carbon, hydrogen and less percentage of fixed carbon, sulfur and ash percentages. So today's session already will learn what is ultimate analysis. What is ultimate analysis? It is mainly used for coal is used for some special industrial application purpose. That means it is suitable or not. It can be decided by it can be calculated or analyzed by this ultimate analysis. That purpose we can determine the percentage of carbon, hydrogen and nitrogen, sulfur, ash and fixed carbon. So how can we determine? We can in this ultimate analysis we can discuss just now only, and its significance also we discussed already. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.